Hi, welcome back, IntroStat students. So today we will do the exercise writing null and alternative hypothesis. So, um, why do we write hypothesis? Like, what's the need to write a null hypothesis? So, null hypothesis, right? Hypothesis is we usually abbreviate it to write H naught. Okay, then colon, and then we write whatever that statement is. And then we have an alternate hypothesis, right? Alternative hypothesis. Okay, alternative hypothesis, and the abbreviation is HA, right? And then we have that. So obviously, if H naught is like this is one, then alternate hypothesis is this is not one, right? So usually you need to read the question. So here, let's read the question. A newspaper report claims that 30% of all tea drinkers prefer green tea to black tea. I actually love green tea. Leo is the office manager at a company with thousands of employees. He wonders if the newspaper's claim holds true at his company. To find out, Leo asked a simple random sample of 125 tea drinking employees which they prefer. Do they prefer green tea or black tea? So here, Leo's null hypothesis is right the proportion of all tea drinkers at the company that prefer green tea to black tea is. So when you write your null hypothesis, you always want to write what the claim is. So here the claim is 30. And he says he wonders if the newspaper's claim holds true. So if the newspaper, so the null hypothesis usually, right, usually we refers to when the claim is true. So here, if the newspaper's claim is true, what would be the proportion of all tea drinkers at the company? If it's true. So if it's true, then the H naught is the null hypothesis would be the proportion of all tea drinkers at the company that prefers green tea to black tea is equals to 30%. Right, that's if it's true. So let's read this. A fast food company advertises that the pre-cooked weight for its burgers is on average 0.2 kilogram. The company runs a regular quality control test that involves weighing a sample of burgers to see if the burgers are too light or too heavy. If the sample mean weight is significantly different than zero point 0.2 kilogram, then they recycle the whole entire batch. So, look, the fast food company advertises that the pre-cooked weight for its burger is on average zero point 0.2. So this is what the fast food company is claiming, right? That's their claim. So the null hypothesis will be their claim. So typically, we when you write that, what are the appropriate hypotheses for the company's significance test? When you want to test something, we are not testing about sample mean, right? We're not testing about sample mean. So A and B, they're out, right? Look, this is sample mean, sample mean, sample mean, sample mean. We are actually testing for the population mean, right? Population mean. So population, the very first one is that the claim should be the claim, right? The population mean, sorry, should be the claim, and the claim is zero point 0.2. Then the alternate hypothesis is not equals to zero point 0.2. Why? Because if the sample mean weight is significantly different, they didn't say less, they didn't say more, they say significantly different. So as long as it's different, which is another way to say it's different is not equals to, right? Zero point 0.2, that would make the alternate hypothesis. So the null is population mean equals to 0.2, and the alternate hypothesis is the population mean is not equals to 0.2. Okay, so a ketchup company regularly receives large shipments of tomatoes. And for each shipment that is received, a supervisor takes a random sample of 500 tomatoes to see what percent of sample is bruised and performs a significance test. If the sample shows convincing evidence that more than 10% of the entire shipment is bruised, then they will request a new shipment of tomatoes. So let P represent the proportion of tomatoes in the shipment that are bruised. So this P refers to the population proportion of tomatoes in a shipment that are bruised. Okay? So, and what's the claim? The claim is that, right, if the sample shows convincing evidence that more than 10%. So as long as it's 10%, right? If the population proportion is 10%, hey, that's good, right? That's the null hypothesis. But the alternate is if it's more than 10%, what happens if it's more? So that's your alternate hypothesis. So, by the way, for your null, it's always equals to, right? We don't have this. Your null cannot ever have more than, less than, or not equals to. So B is out, right? B is out. So it's either A, C, or D, right? So you have equals to 0.1. C is the null hypothesis is 0.1. D is null hypothesis 0.1. That's cool. Now the alternate hypothesis is that what if it's more than 0.1, right? So this is not equals to, no, actually this is the one we need. Okay, I will try to do another one. So the National Sleep Foundation recommends that teenagers aged 14 to 17 years old get at least 8 hours of sleep per night for proper health and wellness. A statistics class at a large high school suspects that students at their school are getting less than 8 hours of sleep on average. To test their theory, they randomly sample 42 of these students and ask how many hours of sleep they get per night. The mean for the sample is x bar equals to 7.5. So when you do a hypothesis, right, the average amount of sleep students at their school gets per night is, so what's the claim? The claim is that the at least 8 hours of sleep, right? At least eight. So at least eight, which means the at least eight. So if we cannot use less than or equals to, we have to use equals, right? So your null hypothesis will be that the average amount of sleep is equals to, right? The mean is equals to 8. Right? The mean is equals to 8. So that's the claim. At least 8, right? At least 8. So here the alternate hypothesis, what are you suspecting? You're suspecting that they are getting less, right? That you suspect that they are getting less. So the alternate hypothesis is it's less, right? It's less than 8 hours. Okay, so if you have any questions, let me know. Thank you very much.